If you wanted to find the expected value of a discrete random variable, then it's helpful to think about how you would calculate the mean of a discrete variable which is displayed in a frequency table. If you look here, you can see that we have a frequency table, and from that we're able to make an illustration, which is this bar chart here. And in this bar chart we have got 12 threes, we have 15 fours, 10 fives, 8 sixes and 4 sevens. So to find the mean of those 49 y values, we need to work out what 12 threes, 15 fours, 10 fives, 8 sixes and 4 sevens are, which we've done just here. And then we need to divide that total, 222, by the 49 values of y, which we have here, giving us a mean of 4.53. Now, if x is a discrete random variable, then instead of a frequency table we have a probability distribution. And we can illustrate that with a graph very similar to a bar chart. But now you'll notice that instead of having heights which are frequencies, these heights are in fact probabilities. So whereas before we multiplied by the frequencies, if you look down here you'll see that we've multiplied by the probabilities. 0.15 here was the height of this first bar, 0.2 was the height of the second bar, and so on. Now when considering the discrete variable we needed the frequencies, but here we have probabilities, and we need to divide by the total frequency on the normal variable, but here we have a random variable, and if you add up the total probability you'll find that it makes 1. So down here where we needed to calculate the sum of all the products, now instead we are just dividing by 1, so we don't need to bother dividing by 1. The sum that we've put here is the answer that we were searching for, the mean. So to summarize, if you were to find the mean or the expected value of a discrete random variable, all you need to calculate are the products of each x value with its probability, and if you pair up each of these and sum those products, you will get your expected value that you were required to do. The expected value is the same as the mean because over the course of many trials we know that most random variables regress to that mean value. You get as many values above the mean as you get below the mean. So things average out, hence the expected value is called the mean. Now, if you want to find the expected value of a function which has been applied to that random variable, such as x squared or 5x minus 3 or 4x, then that function has only been applied to the x values themselves. So the probabilities that are attached to the x values, such as 0.15 or 0.2, 0.25, those probabilities are unchanged. So you only need to apply the function to the x values. So 3 has been squared because we are looking here for the expected value of x squared. So if I square 3, it gives me 9, and multiply it by the original probability attached to 3, 0.15, it gives me the required product. So if you look here, to find the expected value of x squared, I've only had to square the x values. I've not had to do anything to the probabilities, and that gives me quite an easy calculation. So if you look at the calculations required to find the expected value of x squared and compare them to the calculations required to find the original expected value of x, you should see the similarities. The probabilities are unchanged. What's been affected has just been the x values have been squared here to give me the final solution. The expected value of x squared is 27.28.